All right, guys, let's have some fun here debunking Aron Ra and defending a literal Adam and Eve and, of course, separate ancestry. And so I am going to get right into it by sharing my screen and allowing Aron Ra to make his anti-Adam and Eve argument, and then I am going to respond. So here we go.
So they couldn't have been written or given or dictated by any gods or angels because they would have known better. We have sufficient evidence in science to prove that Adam and Eve are genetically impossible and were not real people. The global population cannot have been derived from a single couple, not 6,000 years ago, nor even 600,000 years ago. We descend from a particular population of apes, numbering several thousand strong at least, who set out on the road to our lineage at least a few million years ago. To be clear, this is a matter of objectively demonstrable scientific fact, not assumptions. Physical anthropologists and paleoprimatologists can show how humans and chimpanzees share a common ancestry is an objectively verifiable fact in the absolute sense that it doesn't change, meaning that it will not be corrected by new information. It's not just a probability, it's a certainty. Cultural anthropologists can also
Okay, there we have it, folks. So Aron Ra has asserted, Aron Ra has claimed that there is no evidence for a literal Adam and Eve, and as a matter of fact, it is impossible that we have all descended from just two people thousands of years ago. And so, what I want to do is go through some slides and go through several genetics-based reasons and genetic-based arguments for why the historical Adam and Eve, the biblical Adam and Eve, truly existed, and separate ancestry is the best scientific model in terms of origins. Now, I am going to break this up into at least two parts. So we'll see how much I cover in this specific video, because there is overwhelming evidence for a literal Adam and Eve. And I want to keep these videos digestible. And so I don't want to throw too much information at you. I want to give you enough information per video to absorb, to understand, and then eventually utilize against the critics, such as Aron Ra, who attack the biblical Adam and the biblical Eve. So firstly, I have written just a ton on this issue. I have debated it numerous times. I've engaged the critics. I've debated PhD evolutionists on this. Aron Ra, unfortunately, is out of date on the best lines of evidence and argumentation for separate ancestry and the biblical Adam and Eve. The best way to answer the question of ancestry is through our genetics. The reason why is because it is in our genomes, it is through our traits and our genes that we can answer this important question of ancestry, because it's genes, it's traits that are inherited sperm and egg. A rock is not inherited sperm and egg. A bone is not inherited sperm and egg. Aron Ra's assertions and claims are not inherited sperm and egg, because that's all he's provided are assertions and claims. We want assertions and claims to be backed by scientific evidence. You just saying that something is backed by scientific evidence without providing that evidence is pretty well worthless. Okay. Geography is not inherited sperm and egg, geology, so on and so forth. So genetics is a direct way for us to answer this question of ancestry. So I've written several books. Here are two of the main ones. Special Creation. This gets into a lot of the evidence that we'll be discussing in this video and at least one other video, going over mitochondrial Eve, Y chromosome Noah, out of Africa versus out of Middle East, junk DNA, chromosome 2 fusion, so on and so forth. I've written an entire book. I've dedicated an entire 200-page book to addressing endogenous retroviruses and demonstrating why the evolutionist camp's best argument for common descent, ERVs, actually turns out to be some amazing evidence for separate ancestry, for special creation, and for intelligent design. And so I do highly recommend checking these books out. Now, the model that Aron Ra holds to would be universal common ancestry. And so he would argue that all life, including plants, including animals, therefore including strawberries, whales, humans, chimpanzees, and so on and so forth, are related to a common ancestor. And so this is a more sophisticated representation of what the universal common ancestry model teaches. We are related to every single living thing. As you can see here on the tree, you've got fish, amphibians, reptiles, birds, mammals, all related, all going back to a single-celled like ancestor billions of years ago. Right here, same thing, amphibians, grasses, humans, whales, green algae, all going back to a common ancestor. I've done entire presentations on the separate ancestry model. Here's just a basic phylogeny where we've got humans existing separately and independently from any other form of life. And that includes your chimpanzees, that includes your gorillas, your orangutans, so on and so forth. And so I want to get into just a few of the many lines of evidence for a literal Adam and Eve. And so let's start with, I find it funny the way that Aron Ra says it's impossible. Well, right off the bat, you can tell that he is assuming what many in the theistic evolutionist camp have argued and assumed, that Adam and Eve, if they were created, they would have been created genetically homogeneous, okay, rather than genetically heterozygous. This goes back to basic genetics and alleles. Allele referring to a genetic variant. Okay, you got capital A, lowercase a, capital B, lowercase b. You would be genetically heterozygous in that instance. If you're capital A, capital A, capital B, well, then you'd be genetically homogeneous. You've got no DNA diversity, no variety at that genetic loci or location. But if you're a capital A, lowercase a, then you would have a genetic variant. You would have DNA diversity. And so if you apply this to millions of positions within the genome, then Adam and Eve would have been created with amazing potential for variation, for change, for adaptation. Just through processes like recombination and gene conversion, recombination having to do with the reshuffling of those pre-existing DNA variants every single generation as the chromosomes line up and the chromosomes essentially exchange genetic information with each other. That's why you have 50% of your mom's DNA, 50% of your dad's DNA. As a matter of fact, you could hypothetically have 1 million kids, and every single one of those kids would be different. They would look different because we have built-in heterozygosity. We are heterozygous at about 3 million sites. And if Adam and Eve were heterozygous at between 10 to 20 million sites, then through those pre-existing DNA variants, you could explain every single shade of skin on the planet today. If Adam and Eve were a middle skin brown, let's say for skin color, capital A, lowercase a, capital B, lowercase b, from those pre-existing DNA differences, over time, you'd get every single variation of human that we see today, just through simple heterozygosity. God creates the original created kinds with internal diversity, and that pre-existing diversity can be manifested in real morphological and phenotypic diversity and change, novel morphological features, not anatomical, but morphological variation, simply due to the reshuffling of those DNA variants, simply due to what the evolutionists would oftentimes look to in terms of speciation, where you have a subgroup of a greater population, of a parent population. They basically separate, they migrate, they become isolated from that parent population. You have a daughter population, okay? And from there, you get shifts in heterozygosity, which is just more allelic variability, to homozygosity, which is less allelic variability. You get inbreeding, you get new variation. But here's the thing, creatures hit walls over time because there's only so many shifts in heterozygosity to homozygosity that can take place. And so there is a lot of built-in morphological variability in each created kind. And so when Aron Ra says it's just impossible, there's no way we could have all descended from just two people, that is assuming evolutionary creationism, where Adam and Eve are created with no DNA diversity. That wouldn't make sense theologically. That wouldn't make sense scientifically. When God said to be fruitful and multiply, did he mean for that to be carried out through cloning? Of course not. And so scientifically and theologically, it makes sense that God would have created Adam and Eve with the ability to vary in terms of their progeny and their offspring. And so they would have been created genetically heterozygous. And that is not post hoc ad hoc, because that makes testable predictions. It makes testable predictions on DNA function. And it makes testable predictions on speciation rates, for example. The DNA function related prediction is interesting because we have amazing evidence for genome-wide activity, specifically biochemical activity. And I've done entire shows on junk DNA refuting. I've debated the topic, refuting this argument that, well, most of that activity is spurious. Most of that activity is just noise. Well, if that really is the case, then transcription, every time you add a single nucleotide to a growing RNA change, that is consuming energy. It is consuming ATP. Transcription is an energy-intensive and resource-intensive process. It costs energy to transcribe DNA into RNA. You got DNA transcribed into RNA, translated into proteins. But it doesn't always end with a protein. Oftentimes you get DNA to RNA and you get a functional RNA transcript. That requires energy. As a matter of fact, only about 2% of the genome is protein coding. The rest of the genome is heavy in regulation. You name the DNA element, whether it's ERVs, ALU sequences, pseudogenes, they have all been demonstrated to be necessary to sustain healthy life processes in the cell. And this is exactly what the created heterozygosity hypothesis would predict, that the majority of the genome is functional, is useful, is beneficial. And this is what we're finding. And know that activity, that biochemical activity, is not just noise, because that would be wasteful of energy and resources to transcribe or to utilize all of this binding when it comes to transcription factors. Okay. And there's a couple points that I wanted to make when it comes to the evolutionary argument that most of this is basically just evolutionary leftovers. Well, if that's the case, over millions of years, processes like natural selection should have weeded out this genetic baggage, because again, that would just gum up operations in the cell. It would be wasteful of energy and resources for the cell. And so evolutionary processes should be able to neutralize that junk. The fact that it's there tells us that it's there for a reason. I've talked about how transcription factors, these proteins that assist in regulating the transcription of genes, okay, they basically bind to certain areas of our DNA, and they ensure that the right genes are being turned on and expressed at the right time. And there is a lot of transcription factor binding that has been discovered in these genome function related tests and projects, like with the ENCODE project. And so if there's transcription factor binding taking place in the genome, that is most likely functional binding, because if it wasn't, and this binding was just happening randomly, it was just spurious, it was just noise, haphazard binding, then again, that would gum up operations in the cell. There wouldn't be enough of these transcription factors to go around to actually do the necessary binding to transcribe DNA into RNA. And so that's just a couple reasons why their rescue devices in terms of the activity don't work. Okay, so mitochondrial Eve. Well, mitochondrial Eve. What do we have? We have mitochondrial DNA, the powerhouse of the cell. Okay, outside of the nucleus. This is a very interesting DNA compartment. It's about 16,000 letters long. And the mitochondrial DNA is what's called uniparentally inherited DNA. What that means is it's passed down on only one side. So mitochondrial DNA specifically is passed down on the mother's side. Well, it turns out that worldwide mitochondrial DNA, you could build a family tree using mitochondrial DNA, and mitochondrial DNA goes back to a single mitochondrial DNA ancestor, not a couple 100,000 years ago, but only about 6,000 years ago. Mitochondrial DNA worldwide has very low variation. The mutation rate using the pedigree method. So you can do trio studies where you've got grandmother, mother, daughter. Count up the differences each generation. You come up with a very high mutation rate, way higher than the phylogenetic rate that the evolutionists look to, and way higher than has ever been predicted by the evolutionists. And so in the mitochondrial DNA, it's somewhere between 0.1 and 0.5 per generation. That's high, especially in light of the fact that in the mitochondrial DNA worldwide, there's only about 20 to 25 DNA differences separating any two people. That's trivial. If we've been evolving and adding mutations for a couple 100,000 years since the out of Africa bottleneck, then there should be more DNA variation. There should be a lot more DNA differences separating any two people. So we've got evidence in our genome, in genetics, for one woman of whom we've all descended from. We've got the same thing with Y chromosome. Y chromosome DNA is also uniparentally inherited. It's not autosomal DNA. It is nuclear DNA, but it's not autosomal DNA. It experiences basically no recombination except at the tips. And so it should be relatively more stable. And yet all worldwide male Y chromosomal DNA is nearly identical. Every single male Y chromosome on the planet can be traced back to a single Y chromosomal ancestor in the not so distant past. The Y chromosome is also rapidly mutating. It accumulates about 3 new mutations per person per generation. Okay. On the male side, obviously, it's inherited from our fathers. And even on the low end, at 1 per generation, it's far too fast in light of the fact that the Y chromosomal DNA compartment is very low in terms of variation. Okay. And what the evolutionists have attempted in terms of a rescue device is what's called coalescence. Okay. So they assume, basically, just through mathematics, given enough time, that you are going to just naturally land on a single mitochondrial ancestor in the past, a single Y chromosome ancestor in the past. But that's not true, because coalescence actually assumes what's called random mating. But there is no random mating. Historically, people have existed in tribes, they've existed in isolation, and they tend to marry within those tribes. And so on the earth, you'd have isolated tribes here, isolated tribes here, isolated tribes here, and they'd be separated geographically. They'd be intermarrying, interbreeding within those tribes. And very rarely would you get interbreeding outside of the tribes, where one tribe comes to another. Okay, so what that means is, if evolution is true, we shouldn't have a single mitochondrial DNA ancestor, nor should we have a single Y chromosomal ancestor. We should have many mitochondrial DNA ancestors and many Y chromosomal DNA ancestors, but we don't find that. We find a single Y chromosomal ancestor and a single mitochondrial DNA ancestor. Another thing is, if we actually share a common ancestor with the great apes, as Aron Ra would want us to believe, and how he's what he's purporting here, that we've descended from populations of non-human apes. Well, if we really share a common ancestor with the great apes like the chimpanzees, bonobos, gorillas, orangutans, and we split from a common ancestor with our supposed closest living relative, the chimpanzee, millions of years ago, we would have essentially split from a common ancestral population. And this common ancestral population would have had numerous genes floating around. Now, this ancestral population that apparently we would have shared with the chimpanzees, they would have had a diversity of Y chromosomes. It wouldn't have just been complete uniformity. There would have been a diversity of Y chromosomes. And as that ancestral population diverges into different groups, for example, you have one group, humans, another group, chimpanzees, both going their separate ways, two different lineages. One group, let's say humans, could conceivably comprise individuals that are more different to each other than they are to the chimpanzee on the Y chromosome. But this isn't the case, even though it could have been if humans and chimpanzees split from a common ancestral gene pool. Genetic entropy, I will save for another video. Design diversity and DNA function, we briefly touched on that one. Okay, so first we're going to look at the mitochondrial DNA here. Okay, so we have, again, I touched on the mitochondrial DNA, this piece of DNA that we only get from the mother's side. It's passed down basically intact from generation to generation. This is why we call it uniparentally inherited DNA. Now, as mutations accumulate, new branches on this family tree or phylogenetic tree are formed. Now, we can actually look at mitochondrial DNA in people groups worldwide. Okay, so for example, this is the HVR haplogroup, most common in Europe, if I'm not mistaken. And what's interesting is you'll notice that the branches, which reflect DNA differences, they are differing in size. So these branches have differing lengths. What that tells us is the molecular clock is not as constant as the evolutionists would like it to be. This tells us that some people are picking up more mutations in the same amount of time than their cousins as they go back to a common ancestor. Well, now you can't really take the phylogenetic approach that basically assumes common ancestry between humans and chimpanzees, counting up the number of DNA differences or mutations, and then dividing by the time that supposedly humans and chimpanzees split from a common ancestor sometime between 6 and 10 million years ago, where they would derive a very small mutation rate. Now, there are some critics that would say, well, we can look to known historical events and we can get a mutation rate that way as well, right? Where certain people groups settled and we know when they settled. And so we can look at it that way. But nonetheless, okay, there are issues with that. But the point is the mutation rate is too fast. Again, in the mitochondrial DNA, it's about 0.5 per generation, okay? And so this tree, there's very little variation on this tree. We see explosive growth from a center point, okay, this starburst pattern. Some evolutionists have a problem with this because it's unrooted. Well, an unrooted tree gives us a natural reflection of the data rather than picking a root, which is based on evolutionary assumptions or creation assumptions. This gives us, again, a very natural reading of the data. So we have a fast mutation rate. We have one woman. We have very low variation. Also, the mutation rates are variable, but in light of a fast mutation rate, when it comes to the rate of fixation of neutral mutations, because the evolutionists want to say, well, you got to look to the substitution or the fixation rate, not the per generation rate. Well, the problem is the rate of fixation, and I wrote a technical article with Christopher Rube on this, of neutral mutations. Remember, neutral mutations, okay? In a population, those are the unselectable ones, actually equals the neutral mutation rate. So the neutral mutation rate, the per generation neutral mutation rate equals the long-term substitution rate or the fixation rate. That's basic population genetics. And so, for example, if the rate of mutation accumulation is 1 per generation, and then let's say you have 1 million individuals, well, the population of 1 million will be substituting one letter in its genome every generation because of neutral mutations. And so looking to the fixation rate or the neutral mutation rate, like PhDs in evolutionary biology like to look to, does not solve the problem. Again, when we use real world empirical mutation rates, where we actually measure mutations from one generation to the next, again, you can get grandmother, mother, and daughter, the mutation rate is quite high. Known data on genetic variation in the mitochondrial DNA compartment and the Y chromosomal DNA compartment demonstrate that these DNA compartments, these uniparentally inherited DNA compartments, are young. And so Eve did not live a couple 100,000 years ago. Our last Y chromosomal ancestor, specifically Noah, did not exist a couple 100,000 years ago. No, they lived just thousands of years ago. This is biblical time right here. To generate this amount of diversity is trivial. The same thing goes for the Y chromosome. You see a very similar pattern. Variation in the Y chromosome is quite low. We have evidence for one man. The mutation rate is high, somewhere between 1 and 3 per generation. And so it doesn't take much time to generate this amount of diversity. And again, we have people groups here. This is worldwide Y chromosomal DNA. When you bring in the chimpanzee, it turns out that when you consider overall gene content, architecture, and size differences, and I challenge Aron Ra to refute this, the Y chromosomes between humans and chimpanzees are only about 35 to 40% the same. They're half the size. They start off at 50% difference. And so we'll touch on that a little bit later, actually. So here is, from the conventional literature, the pedigree rate of mutations accumulating is 10 times higher than phylogenetically derived rates. 10 times higher. Hypermutation is a reality. We understand there's evidence for hypermutation. Environment can influence mutation rates. Some mutation rates are higher in different people groups. Right here, we also found that the overall point mutation rate is significantly higher in Africans than in Europeans in this specific region. So again, mutation rates are variable, and there's the existence again of hypermutations, and there exists the potential for having mutations in important DNA repair enzymes. Notice this. Our findings imply that defects in DNA repair genes can increase germline mutation rates, in addition to their well-established impacts on somatic mutation rates. That means you can't look at a people group that has more diversity, let's say in Africa, and assume a constant rate and assume, well, because they have more diversity or evidence for more mutation accumulation over time means they're older. No, again, mutation rates can vary. Hypermutation exists. Certain parts of the genome can mutate quicker. So I want to address this real quick, because you'll notice on both the Y chromosome and the mitochondrial DNA, your African lines are the longest, because Africans do have the most genetic diversity, and your non-African haplogroups actually nest within African haplogroups. And so evolutionists arguing for the out of Africa theory will argue for it because Africa has the most diversity in humans. And again, everything basically nests within Africa. So they conclude, well, Africans must be older than non-Africans, and therefore your out of Middle East or out of Babel model is false. But firstly, what they don't realize is that everything is going to nest within the epicenter of genetic variation, of genetic diversity. Okay, so the epicenter of where we've all originated or dispersed from, that is where everything is going to nest. But it's going to depend on where you place the epicenter of genetic diversity. Well, the epicenter of genetic diversity is very close to the Middle East. It's right in Africa, very close to the Middle East. But where we actually place that epicenter is based on numerous assumptions. And so they place it in Africa because Africa has the most diversity. And therefore, from there, from that starting point, the side effect is everything is going to nest within it. But it's based on several assumptions, with many of them actually being unknowable. Okay. Realistically, all we need as creationists in order to refute this argument that says we've all originated from Africa many thousands of years ago is higher mutation rates, which we've demonstrated is a reality, higher mutation rates in African lineages, and also selective sweeps. Let's say there was a selective sweep across Asia. So you basically have people moving into Eurasia after the Tower of Babel, but then you have a selective sweep across Eurasia where your older lineages that have higher diversity are actually replaced with newer lineages. Okay. And the older lineages are basically wiped out. And so that DNA diversity is wiped out with it, or the evidence of it at least. And so now you have newer lineages surviving or remaining in Africa. So you have your older lineages in Africa because they didn't experience a selective sweep, but newer lineages now in Eurasia because there is a selective sweep across Eurasia. Okay. Or Africa could have had an original higher population size. So initially, more people could have moved into Africa from the Middle East. We have waves and waves of people coming into Africa. And as they move into Africa, they're bringing lots of diversity with them. Okay. And so one of those or all of those possibilities could explain why the African populations have more diversity. Also, in Africa, you have the most diversity in terms of environment. And environment can dictate morphology, can help dictate levels of genetic variation. We didn't even get into PRDM9 enzymes, or genes that basically help initiate recombination. Doesn't necessarily apply all that much to the uniparentally inherited DNA compartments, but that can help with a more shuffled genome. As a matter of fact, the question I have for the evolutionists that believe in the out of Africa model is, why do we still have such large linkage blocks present in the human genome? Linkage blocks, okay, some of them range, you can get 10,000 nucleotides, okay? And so they're linked. But if you're experiencing gene conversion and recombination every generation, then the genome should be a lot more scrambled. We shouldn't have so many large linkage blocks. There's evidence for many linkage blocks in the human genome having experienced no recombination, no scrambling at all. But if we go back hundreds of thousands to millions of years, then the genome should be a lot more scrambled. But it's not. And the reason why it's not as scrambled as it should be is because we've only been experiencing recombination and gene conversion since the last bottleneck, which was at the flood. As a matter of fact, the evolutionists really struggle with the level of genetic diversity in human beings as a whole. Okay, starting from the biblical model, and I want Aron Ra to address this, we start with two people. God creates two people, Adam and Eve. From that starting point, genetic diversity is restricted. What do we find today? Humans have incredibly low levels of genetic variation, whether it's the autosomal DNA, whether it's the uniparentally inherited DNA compartments, it's all low. But if the evolutionary model is true, and we've been evolving for millions of years, from Australopithecine-like ancestors up to Homo habilis, up to Erectus, who apparently lived on the globe for 1 million plus years, that brings another question to mind. Where is all the evidence of Erectus living on the globe for 1 million plus years? Let's say Erectus had a generation time of between 20 to 25 years. How many kids could you have in 1 million years? Well, we should find billions of dead bodies that are Erectus, Homo erectus. Even the evolutionists would agree that Erectus was a sophisticated people group. There's evidence of controlled use of fire, purposeful navigation. They were an intelligent people group. So where's all the evidence for their campsites, for their civilizations? Where's all the evidence of their bones, the billions of Erectus bones that we should find? Because if they lived on the globe for 1 million plus years, why can we fit basically every single Erectus bone in the trunk of a car for the most part? Where's the evidence that they existed on this planet for as long as the evolutionists assert? Again, if the evolutionary model is true, since mutations add genetic diversity, because they're adding something that was not previously there, then humans today should have high levels of genetic diversity, but we don't. We have low levels of genetic diversity, and that's exactly what we'd expect if biblical creation were true. Now, as a result, the evolutionists, they didn't predict this, they didn't expect this. And so what they did was they invented a post hoc, ad hoc way of rationalizing out of this. So they invented the out of Africa population bottleneck, this near extinction event that wiped out humans to somewhere between 2 and 10,000. But guess what? This wasn't a 1 generation bottleneck. This wouldn't have been a 2 generation bottleneck. This would have been an extended population bottleneck. In order to reduce the necessary levels of heterozygosity and increase the necessary levels of homozygosity to basically bring humans to where they are in terms of genetic variation, you would need a bottleneck, a near extinction event that lasts thousands of years. But you know what would occur in those thousands of years is inbreeding, severe inbreeding. What does inbreeding do? It reveals the hidden reservoir of genetic mistakes that have been accumulating. These recessive mutations come to the forefront. They lead to disease, they lead to damage, they degenerate. Populations don't get better through near extinction events that are prolonged, where the population remains somewhere between 2 and 10,000 for X number of years. This idea that from this nearly extinct population of humans, they basically spread out into all parts of the globe, seizing dominion over the planet, that's not feasible, because that population of human beings would have been genetically compromised. It's not like the biblical bottleneck where you have Adam and Eve, a single generation bottleneck that's followed up with rapid and exponential population growth. Then at the flood, you have a single generation bottleneck with 8 people, Noah, his wife, their 3 sons, Shem, Ham, and Japheth, and their 3 wives. What follows that? Rapid and exponential population growth. And then you get to the Tower of Babel, and it's not long before the languages are confused, and then people start spreading out into all parts of the globe. And that explains why we have geographically specific Y chromosomes. We have African Y chromosomes. Notice this. We have African Y chromosomes, European Y chromosomes, Chinese Y chromosomes. It's because, and this goes for allele frequencies in general, okay, when people spread out, people groups start spreading out after Babel, well, they are now isolated from each other. And so they're accumulating their own independent mutations. So different people groups have spread out to different parts of the globe. Each group is accumulating their own mutations, let's say in this instance in the Y chromosome. And so they become Y chromosome specific. Even though worldwide, there's uniformity in terms of the variation of the Y chromosomes, there's geographically specific Y chromosomes. That points us right back to the Tower of Babel dispersal. We also find that with allele frequencies. Okay, when we look to common alleles versus rare alleles, and a lot of your rare alleles are in subpopulations, they're isolated to subgroups, which makes sense because, again, as people move out into different parts of the globe, they start accumulating their own unique mutations. And all of this screams the Tower of Babel. All of this screams the out of Middle East model. And Aron Ra, he's ignorant of this scientific data. There is plenty of scientific evidence for a literal Adam and Eve. Now, I do also want to get into the Y chromosomal dissimilarity between humans and chimpanzees. There's a few other arguments I want to get into as well. I want to get more into DNA function, but I'm going to save that for a part 2, as I've already reached the 40-minute mark. And so I hope people enjoyed this. I really wanted to demonstrate why all Aron Ra has are assertions. He has claims, and these claims aren't based on real evidence, because the real scientific evidence tells us that we have evidence for one mitochondrial DNA ancestor from whom we've all descended from. We've got a single Y chromosomal DNA ancestor that we've all descended from. We've got the mother of us all. We've got the father of us all. We don't have a huge diversity of Y chromosomes. We don't have a huge diversity of mitochondrial DNA. Again, we have evidence of two ancestors, the first couple, the first parents, And to argue that all humans could not have descended from them argues against a straw man, because Aron Ra assumes that God would not have created Adam and Eve with pre-existing heterozygosity, with pre-existing DNA diversity. And this model of design diversity makes very specific predictions on DNA function, makes very specific predictions on speciation rates. And so I think we're going to wrap it up there, as I have hit basically the 40-minute mark. And so again, thanks for watching the video, guys. Share this content around, because the truth is important. And I'm here to tell you, it is a great time to be a biblical creationist. God bless all.